This video goes through the Chapter 7 test review. Number 1. 2 points on line K are -4, 3, and 2, -1. Write a ratio expressing the slope of K. So the slope formula is y2 minus y1 over x2 minus x1, or the change in y over the change in x. So if we look at the two different y coordinates, we can subtract them, -1 minus 3, and on the bottom we would put 2 minus a -4. And this is where most people make a mistake. When you subtract a negative, that becomes like addition. So -4 goes on top, and 6 goes on bottom. If we simplify, we get -2/3. So we can think about slope as a ratio, because on this line, slope is rise over run. So every time we rise -2, in other words, go down 2, we go right 3. Every time we go down 2, we go right 3. And if we kept doing that, we'd end up from one point to the next. Number 2 asks us to solve this proportion 3x is to 32 as 3 is to 2x. So the best strategy here is probably cross multiplication, which means we're going to take 3x multiplied by 2x on one side of the equation and set that equal to 32 times 3 on the other side. So if we multiply the coefficients 3 times 2, we'd get 6. And there are two x's, so our exponent becomes 2. And 32 times 3 is going to be 96. We divide by 6 on both sides. We get that x squared is equal to 16. To get x by itself here, I'm going to take the square root of both sides, and x is going to be 4. So we would have ended up with 12 is to 32 as 3 is to 8. And both of those, if you take the number on the right and you multiply by 4, you get the number on the left, so everything looks good. Number 3, given that 6x is equal to 14y, find the ratio of y to x in simplest terms. So this part right here where it says y to x, another version of that is y over x. So that's what we're going to try to solve from this equation. In other words, we're going to have to move the 14 over and move the x over, and we'll be there. So if we start off with 6x is equal to 14y, and we divide both sides by 14, we end up with 6/14 x is equal to y. So then we can divide both sides by an x to cancel out the x on this side, and there we have it. Y over x equals something. The last question to ask is, can we simplify this at all? And it turns out if we divide both by 2, we get 3/7. So that is our answer, the ratio of y to x in simplest form, 3:7. 4 reads there are 66 grams of protein in a 12-ounce serving of salmon. How many grams of protein are in a 4-ounce serving? So if we use our units, this becomes an easier proportion to set up. We know it's 66 grams per 12 ounces. So the other number we're given is 4 ounces. Would that go on the top or the bottom of the other ratio? Well, since ounces are on the bottom over here, they have to go on the bottom over here also. So this is going to be 4 ounces also. So this is going to be x grams. And that's how we figure that out. Then we cross multiply. 66 times 4 divided by 12. The final answer there is 22 grams, if you cross multiply correctly. So for 5, we're going to match up the appropriate sides. We know that AB would match up with DE. So I'm going to match up 4.5 with 10.8. Next, BC should match with EF. So BC here in green and EF here in green. You can't just go by the picture. And the third side remaining, 3.2 divided by 6.4. Because those are the only two sides left. So the question is, are these proportional? Do these three ratios have an equivalent scale factor? And the answer is no. This one's 1/2. This one's definitely not, so they're different. So this one is not similar. However, if I change the order of the letters in the second triangle, originally it was DEF, and if I change it to FED, now these can be similar, because AB is 4.5 and FE is 9, it's just double, and BC is 5.4, where ED is 10.8, which is just double, and the last one, 3.2 and 6.4. So the order of that second triangle mattered. The ratio between these is 1:2. Number 6, Jamestown, North Dakota claims to have the world's largest bison, or American buffalo, statue. The statue is 26 feet high, 46 feet long, and 14 feet wide. The statue is similar to an actual bison that is 6 feet tall. So I'm going to set up a ratio here between the statue and the actual bison. And we'll do this in 3 different measurements. First up is how many feet tall. So this is the height. And the statue is 26 feet, and the actual bison is 6 feet tall. So they want to know about the length, so how long is the statue compared to the actual. So I could set it up like this. I would put 46 on top, because that corresponds with the statue. Across the top, everything is statue measurements, and along the bottom, everything is actual measurements. Here I can cross multiply. 46 times 6 divided by 26. And if I do so correctly, my final answer here is 10.6 feet. In number 7, we have 2 triangles. We are given that K and H are both 64 degrees. Those angles are congruent. And we can recognize that these 2 angles here in red are also going to be congruent because they are vertical angles. When 2 straight lines cross, the angles opposite each other are equal, like here. And the thing about triangles is that the angles have to add up to 180. So if 2 of them are equal, the third one is equal too. That's the angle-angle shortcut for congruency, or for similarity. And to match these up, we know that H and K have to be the same. So let's go ahead and put those first in our congruency statements, similarity statements rather. And let's pick the next one, J, because J is equal to itself. And the third one, G and L, and there's our statement. We have now matched up each of the angles that are congruent to write about the triangles that are similar. Number 8 asks us to find SP. So there's lots of different measurements in this triangle, and it's tempting to try to just figure out some of the blank ones, but we have to figure out what SP actually is. SP is this entire bottom of the larger triangle. There's a couple different ways I could go about solving this. The one that jumps out to me is, what if I compare QP, which is the side of the smaller triangle, to 14, which is the side of the bigger triangle. And we set that equal to PR, which is the side of this smaller triangle, compared to SP, which is the larger triangle. If I cross multiply here, 14 times 12, and I divide by 7, I get an answer of 24. Of course, you probably just noticed that 7 times 2 and 12 times 2, you can get an answer without cross multiplying. Number 9 again requires you to pay close attention to what they're asking for. They're asking for this entire side length, BC. My preferred method on these type of triangles is just to draw a fraction bar straight across. And that allows me to say that 12.5 is to 7.5 as 3y minus 2 is to y plus 2. If I cross multiply this, I take 12.5 times the quantity y plus 2, which I'll leave in parentheses. And on the other side, I have 7.5 times the quantity 3y minus 2, which I will also leave in parentheses. I have to remember to distribute this outside term to both numbers or both values inside of the parentheses. If I do so correctly, I'm going to end up with 12.5y plus 25 is equal to 22.5y minus 15. So I will subtract 12.5y from both sides just because that's the smaller value of y. The y's cancel out on the left. I'll go ahead and add 15 to both sides to move the numbers over. This gives me that 40 is equal to 10y. If I divide both of those by 10, I get 4 is equal to y. So I can take this back up into my original equation here, that 3y minus 2 and y plus 2 are the parts that make up this entire side BC. If I solve these, I get 10 and 6, and if I add these two together, my final answer is 16. For this next one, number 10, finding PR, we have an angle bisector here. So I'll draw my line like this, and I'll say 6 over 2x is equal to 3x over 25. Cross multiplying is going to give me 150 is equal to 6x squared. If I divide both sides by 6, I end up with 25 is equal to x squared, and I think we can see where this is going. Once you take the square root of both sides, you get 5. They want to know what PR is, so PR back over here is 2 times 5, which is just 10. And that's my final answer. Number 11. One afternoon, a student who is 5 feet 4 inches tall measured shadows to find the height of a telephone pole. The student's shadow is 5 feet long At the same time, the shadow of the telephone pole was 18 feet 9 inches long. How tall is the telephone pole? So I like to start off by deciding which one I'm going to put on the top and bottom of a ratio. It doesn't really matter. I could put the student on top if I wanted to, as long as I'm consistent. The second thing I have to do is decide on a unit. Am I going to treat these all in terms of feet, or am I going to convert them all to inches? And either method will work. I think we'll go with feet here. So if we think about height, we know the height of the student. That'll go on the bottom of this fraction. We know it's 5 feet and 4 inches. So that's going to be 5.3 repeating. Because if I take 4 inches out of 12 inches, I get that decimal. I don't know the height of the pole. I'm going to leave that as an x. And let's think about the shadow, the length of the shadow. The student's was 5 feet long, so I'll put a 5 on the bottom here. And the telephone pole's was 18 feet and 9 inches long. So I'm going to write that as 18.75. To get 0.75, I took 9 divided by 12. This is what I'm going to cross multiply to figure out my missing value. If I multiply 18.75 times 5.3 repeating, and I divide what I get by 5, the missing height of the pole is 20 feet. If it makes more sense for you to convert these into inches, go for it, and then you could always convert back to feet. Number 12 is about a blueprint for an art gallery. It has a scale of 1 inch, colon 4 feet. That colon there pretty much replaces a fraction bar, so that's going to be 1 over 4. And there's a room that measures 3.5 inches long, and the blueprint, how long is the actual room? So I'm going to choose to put all my blueprint measurements on the top and the actual measurements on the bottom. You could flip it, it doesn't really matter. So I have 1 inch in the blueprint, 4 feet in the actual. Compare that with 3.5 inches on the blueprint and unknown in the actual. So I kept the inches on top and the feet on bottom, and I don't actually have to convert them, though I could. What I'm actually going to do is take 4 times 3.5, which gives me 14, and divide by 1, and it's still just 14 feet. 13, the ratio of the angle measures of a triangle is 4 to 5 to 3. What is the measure of the smallest angle? So I can write this like this, 4x plus 5x plus 3x, and the interior sum of the angles of a triangle is always going to be 180. I could do n minus 2 times 180, but for a triangle, I think we know by now that it's 180. This tells me that 12x is equal to 180. If I divide both sides by 12, this gives me 15 for x. That's not the final answer, though. They want to know the measure of the smallest angle. So which one do you think is smaller, 4x, 5x, or 3x? If you said 3x, you got it. So we'll take 3 times 15, and that actual angle is going to be 45 degrees. 14, KP is 20, KQ is 10, PQ is 30, which is tricky because it's this entire length here. They want to know this proportional one here. There's a couple of different ways to solve this. We can think of PR as x, and then we can compare 20 is to x in the same way that 10 is to 30 minus x. Since we know the whole distance is 30, and we know that this one we're calling x, whatever's left is 30 minus x, we could do it that way. This would tell us that 600 minus 20x is equal to 10x. If we add 20x to both sides, we could get 600 is equal to 30x, so x is equal to 20. And if we want to know what PR is, well, it's just 20. We're done. That method works out pretty well. We have to distribute 20 to this entire expression, which involves some large numbers. Another potential method, if this is 20 and this is 10 and this whole thing is 30, I could say, what's the ratio of 20 to the total of 20 plus 10? And compare that to the ratio of PR to the total of PR plus RQ, which we already know is 30. And if you're paying attention, this ends up being 20 over 30 is equal to what over 30? And PR is just going to be 20, because that's the only number that would fit there. Both of those methods work.